Hi everybody, this is Slava Kurilyak at Produvia, and I am super excited for you to join me on this live stream where we talk about how to generate images using computer vision and deep learning technologies. I am excited for three reasons. Number one, image generation is one of the most trending, one of today's most hottest topics used by companies around the world. Number two, image generation has many elements that you must understand if you are to apply this technology. And number three, I want to be practical. I want to share with you tips and guides and advice that I think will be very beneficial if you and your company choose to implement image generation model at your company. So this live stream is meant to be interactive. For those who join, feel free to leave a comment, feel free to say hi, and let me know where you're from. In the meanwhile, I will briefly introduce myself so you can better understand who I am and where I'm coming from. Like I've mentioned, my name is Slava. I am the founder, CEO at Produvia, where we help companies around the world to develop artificial intelligence technologies so they can scale faster. Being a startup, one of the primary definitions is that it's a company that is built for growth or scale. And so we help these companies to innovate. We help these companies to crush their competition by developing artificial intelligence technologies. This live stream is meant to be educational. I will share with you practical tips on how to leverage image generation models. So let's get started. You will now see on your screen a slide that I put together on how to generate images using CV and DL technologies. And let me make sure everyone will see that first image. Here we go, computer vision. It's important to understand what computer vision is before we talk about image generation or generating images. Computer vision is one of the hottest topics that companies around the world are exploring today. This is a subfield of computer science. It is a subfield of leveraging computers to understand the world around them. Vision models are aiming to understand imagery and video. For the purpose of this particular live stream, I will focus on images exclusively. However, I will be creating another live stream where I go into how to generate videos using computer vision. So keep that in mind. If you're interested, feel free to subscribe and we can have a deeper conversation around that. So let me backtrace and describe computer vision. Computer vision is a subfield of computer science whereby individuals and organizations are aiming to understand imagery data and video data. And computer vision is extremely popular today because much of what we see, much of what we are sort of experiencing in the world is using visual data. And so computer vision is the perfect technology for that. So let me sort of dive a little bit deeper. The next topic that I want to discuss with you is deep learning. Now, computer vision is sort of prerequisite of this particular webinar and or live stream, and deep learning is another powerful technology that we must understand. So deep learning is a technology that is aimed to leverage data and create models that are learning by themselves, right? So the idea is we feed in data from one side and we get some sort of output from the other. Deep learning models are very well designed for something called supervised learning, where we show examples of, this is an input, this is an output. And the more we have of these types of models being developed by companies around the world, the more AI technology is progressing. So this is sort of the second major tech that we're discussing today, which is deep learning. The third concept that I want to describe here is the idea of image generation. Image generation is what we are discussing here, and how it works, we'll get into the details, but image generation aims to create images from scratch, right? We're creating something that did not exist before. We're creating something or generating something that computers are doing And this is the context of image generation. Now, I want to emphasize that there are two image generation or specific models that the academia, the companies around the world are using. Number one, it is the unconditional image generation model. And number two, it is the conditional image generation. Hopefully that shows up on your screen now. The context is that, unconditional image generation is aiming to create images unconditionally, and we'll get into examples of what that means. Conditional is doing so with a guide. So hopefully that gives you an overview of what we're discussing here today. Image generation models are what we're focused on, and really the impact of this technology is quite profound, right? Computer vision as an industry is in the billions of dollars, and it's growing. It's growing in the next 7 years by about 6%. And this is a statistic that I've seen the other day. So the industry itself is expanding. The use cases are expanding, right? So we're talking about any company that's interested to use image generations are usually those who are focusing on something visual. So media companies are the first to leverage this technology. But you also have retailers who are now using this technology to help them generate images for products and clothing. And then you also have sort of the other side where you're aiming to explore image generation for scientific purposes. You're aiming to explore image generation for healthcare reasons. So there are many domains that this technology could be applied across. And my purpose on this live stream is to educate you on some of those use cases. Let me jump further into some of the examples. So the first is where we're talking about unconditional image generation. So what does that mean, right? We're aiming to generate images without constraints. Really, that's the high-level overview. And the method is we're aiming to generate images using a specific model for image generation. And the goal is to generate as high quality and as high resolution as possible, so that that richness of image is now transferred to the use case of the end user. And here it's super important. We're always aiming to generate high quality images. And now image generation models have been around for a long time, and we'll get into some of the most popular image generation models after a few of these slides. But I want to emphasize that image generation is not a new technique. It's not a new model. It's not a new method, but it is very, very powerful. It does use some of the latest technologies related to artificial intelligence. Let me move forward and talk about conditional image generation. Conditional image generation is where we're aiming to generate images where that image is generated conditionally or using constraints. Again, the same goal we have, try to see if we can come up with a high quality image, but now we're making sure the image is generating the specific types of images that based on what our desire is. So I'll give you a few examples, right? Imagine we have lots of images of clothing. Unconditional image generation would give us a new piece of clothing. A conditional image generation, on the other hand, will give us a piece of clothing based on the category that we want, right? So let's say we want to generate a new t-shirt. Now, the conditional image generation is able to generate dozens, hundreds, thousands, or even millions of images for t-shirts. How much value would that bring to you and your company, being able to generate hundreds of thousands of images with a click of a button, right? We're talking about millions and millions of dollars of potential profit. So that profit comes from being able to move products into the market faster, being able to iterate based on media data faster, being able to leverage media in ways that was not possible before. So these are just 3 examples of how you would use image generation to really crush your competition, stay ahead of other companies. Let's get into it. Generative models. Generative models are the best way to describe the technology that's used to generate images, right? Generative models are used to create a model that is creative in nature. It's generating data as opposed to learning from existing data. So I'll give you one distinction, that the model usually, the more traditional models are built based on discrimination or discriminatively, but generative models are aiming to generate data generatively. And here we are creating something that did not exist before. Generative models are creating a new data that it perhaps is based on some examples they've seen before, but that created data, or that new data, generated data, is a data that does not exist. It does not exist in a database. It does not exist from any other example. Right. So a simple way to think of this is that a discriminative model or a more traditional model would learn from one image to recognize what is inside that image. Right. Is that a particular piece of clothing a T-shirt or not? Right. This is like a discriminative model. A generative model is aiming to look at different examples of T-shirts, and it's able to come up with a new T-shirt. Right. So we're now creating a new image that did not exist before. And this is extremely powerful for anyone who's interested to use this tech. And the method here, the method that has enabled this to really sort of go to a new level of realism, to a new level of fidelity, is deep learning. Deep learning technologies is how computer vision models, how generative models have been well adopted. It is how companies around the world are using this technology. They're doing so by leveraging deep learning techniques. So let's break that down. What does that mean, right? Deep learning seems to be related to computer vision, but what is the difference? So deep learning really is aiming to use data, and that data is sort of processed or modeled through a series of techniques. We're leveraging statistics, we're leveraging mathematics, we're leveraging biology to really apply principles and methods on that data and come up with some sort of result. Generative models, on the other hand, are aiming to create data in a novel way. And there, we're actually modifying the deep learning architectures that are very common in supervised learning. And now we're exploring a different type of architecture, and I'll get into examples of what that means for those who are continuing to stay with this live stream until the end. You will see practical examples of what a generative model looks like. And generative models are really aiming to create data, as I've mentioned. Deep learning is aiming to model data effectively, but now we can combine the two. We can combine deep learning and generative models together, and hopefully that makes you a little bit makes it a little bit more clear. So there are many generative models, and I want to bring your attention to 5 of the most popular models, but I also wanted to show you 5 of the most recent models, because sometimes you can learn from the most popular, and sometimes you can learn from what is state of the art, what is the most recent methods for creating generative models. And hopefully this gives you better context. So let's get started. So the first is what is considered an autoencoder. And I'll share with you just the names of these models and the year, but I do want to emphasize that these models are publicly available. These models have been in the academia or research for some time. One of the first, as you can see, one of the more popular examples of generative models is the autoencoder, which was created in 2006, right? Think about that, 2006, right? So we're talking about only 5 years after, I would say 4 years after the computer vision models, which were leveraging deep learning models to make their accuracy be stronger. Only about 4 years since 2012. That's when we saw massive sort of initial adoption of computer vision models using deep learning. In 2016, we see, 2006 actually. That's right. So autoencoders actually are even earlier than that. So 2012, sort of the milestone I mentioned to you, was the milestone where computer vision models were using deep learning to do image generation, computer image classification rather. And 6 years beforehand, we saw that initial definition of the architecture for something called autoencoder, which is now one of the more popular generative models. So hopefully that makes it more clear. And let's give you another example. And this is one of my personal favorites. This is a GAN, G-A-N for short, of generative adversarial networks. GANs were released in 2014. So this is only 6 years ago, right? 6 years ago was the first time that we saw this huge adoption of what are called GANs. And I'll give you a few examples of GAN, and hopefully that gives you a better example. GAN is a architecture whereby we're creating actually two AI systems, right? So one, we are generating some data, and one, we're discriminating against that data. Remember, I've mentioned to you that generative models usually use a generative model or modeling approach. GANs are actually doing two things, right? So one is a generator, one is a discriminator. And the way that these models work is one model or architecture is creating some data, perhaps it's generating images. One is seeing, hey, is this image real? Is this image high fidelity or high definition? And if it's not, it'll go back to the generator and say, hey, go and redo your work, like revisit your method, regenerate the new image for me. So generative adversarial networks, or GANs, are using two architectures, and they're both working synergistically. And all that's doing is simply creating images that look and appear more accurate, more fidelity over time. So what does that look like? So imagine sort of the AI system is unleashed onto a image data set. It's now generating images, and the two architectures are working side by side. And let's say the model has been training for about 1,000 iterations, or in other words, it had 1,000 times the ability to improve itself. Now, if you sort of continue to let it run, and now you're getting to the point of, let's say, 10,000 iterations. Well, the difference between sort of the initial snapshot of 1,000 and 10,000 iterations is that you now are generating a much higher quality image than you were when you were at about 1,000. So when you're at 10,000 iterations, the image quality is higher, and that is because the generative model is creating images that are now harder to be fooled by the discriminator, or harder to fool the discriminator. And so the two are sort of creating, one is creating very high quality images, one is unable to no longer detect, is that image real or not? Is it real or fake? So this is a super high level overview of GAN. Feel free to check it out yourself. Ian Goodfellow was one of the lead core sort of developers, researchers who had developed this architecture, and he has truly, from my perspective, revolutionized deep learning from their generative modeling perspective. That's a mouthful. Let's move forward. The next is the this is called the VAE, the variational autoencoder. So VAE is, I would say, the next best way that companies are using generative models to create images. This architecture came out 1 year before GANs, but they are extremely powerful. Here we're aiming to alter the initial autoencoder architecture, and we're aiming to create a slightly different model that is aiming to really come up with an alternative method for being able to generate data. So VAE is the third most popular, third most cited research that has been used for generating images. The next is Cyclogan. Cyclogan is one of the more recent publications of generative models. Now, and I'll go into another slide where we talk about the most recent, the most recently released, the most publicly released, or rather the most recently publicly released research paper on generative models. That's coming up in another slide. For now, I want to emphasize that Cyclogan is the fourth most popular generative model, and this model came out only 3 years ago. So this is a model that is fairly recent. It has lots of promise, lots of potential, but it is not as good as some of the other three that I've mentioned. So the fifth and final is a denoising autoencoder, and that's a mouthful as well. So that's a architecture that came out after the most popular architecture, autoencoder, in 2008. And here, this model was released slightly before the variational autoencoder, or VAE, but it is another very, very commonly used architecture that is quite useful for anyone who's interested in generating data, or in this case, generating images. So I've mentioned to you 5 of the most popular models for creating images. These models are typically used for what is, I've mentioned to you before, the unconditional image generation. We're creating images without being very explicit about, hey, computer, tell me how these images should look like, just generate images for me. Generative models are by far very well adopted because of these 5 tech architectures, right? So autoencoders, GANs, VAE, Cyclogan, and Denosing autoencoders. Super important that you check them out. I do emphasize that these papers are public. These methods are public. If you want to learn how they work, if you want to use them, go on GitHub, search on Google Scholar, and I am more than happy to guide you in developing these models. So, again, a little bit of a recap. There are 5 of some of the most common models for generating images, and here are the 5 most popular. Now let's move forward. Here is the most recent generative models. So, when will you need to use the most recent? Well, it really depends on your use case, right? So, perhaps you are, a retailer and you want to leverage state-of-the-art methods in using AI technology. Now you would work with myself or somebody else who understands AI technology to develop that custom model. And we, and myself and my team at Produvia, we help companies to develop these models so that they can apply the sort of the tech to solve business problems. And sometimes our discussions lead to asking ourselves, do we need to use state-of-the-art? Do we want to be hitting the 99th percentile in accuracy or 99th percentile in precision milestone? Or, are we okay to use a more popular method? And here we're simply aiming to figure out what is the best model to accomplish our goal. So a retailer may need to generate images of clothing or product lines, and now we're simply asking ourselves, do we need to use something that's more recent, or can we get away with the most popular, the most well-adopted models? What are the most recent models? There are actually many, but I'll focus on 5. So the first is a contextual topic model. And when I say most recent, I do mean those that have been just recently released. And here we're actually talking about the models that have been released in 2020. So that's this year. Most recent models are those that may not see wide adoption yet, but it is something that must be judged retrospectively. It is something that we can only tell with time. So I do want to emphasize that we're not aiming to use the most popular methods here. We're just aiming to look at what are the most relevant in terms of recency. Contextual topic models is the first, most recent generative model that is aiming to really solve the latest problems that people are experiencing today. And here we are aiming to generate images from the contextual topic models. The second most recent model, and again, I highly encourage everyone to check out these models for yourself. Feel free to Google, check out Google Scholar, go to GitHub, and actually see for yourself what these models do and how they work. This one is called TR-LVD-GAN, or short for Generative Adversarial Network. This is another model that came out in 2020, the year when COVID-19 has widely spread, and there are researchers who are dedicating their time to make sure that the image generation problem is solved better than it was yesterday or the year before. And this is the second most recent model, came out 2020. The third is a SIG. These names are quite interesting, so feel free to Google them and see what they stand for and see how they work. SIG is another generative model that's very, very powerful in its ability to generate images. The fourth is another one called NVEA. And again, VEA, I remind you, that is a variational autoencoder. I don't know what N stands for, but I would guess it's a new variational autoencoder. Feel free to Google it and you will find out. And the fifth and final specific generative model, my personal favorite, is a Stylegan. Now this, ladies and gentlemen, is one of the best, I would say, models that you need to understand because of several reasons. Number one, Stylegan version 2 is an improvement of Stylegan version 1. And number two, Stylegan 2 is released by NVIDIA, one of the leading AI hardware companies around the world, a company that has truly revolutionized deep learning thanks to its GPUs and graphical processing units. And number three, the level of accuracy of Stylegan 2 is incredible. You have to see examples of what this looks like, and I will actually pull up on my screen a few examples so you can better understand what I'm talking about. Stylegan 2 is the name. Stylegan 2 was released by NVIDIA, and this technology is truly amazing. So I'll share with you on my screen, first of all, here a GitHub repository to where you can learn more about Stylegan. Stylegan is, you should see it now on your screen, and this is a open source project by NVIDIA. Stylegan 2 is an improvement. Stylegan 2 is really an implementation that has fundamentally altered how the original model worked, but we're now able to generate images. I'll zoom in here for those who are joining. And this is some of the images that we're able to see. Hopefully that comes up a little bit better on your screen. This is the highest quality images that models we can generate today. Now, these are 4 examples of faces that do not exist, right? This is the beauty of artificial intelligence. Stylegan 2 is this architecture where we generate images, and these images do not exist. These people are not real, but we are able to generate these images, and it's very powerful that these models are extremely high fidelity. So if I hopefully zoom in here, I can show you what that looks like. Maybe not from this particular angle, but nonetheless, we're aiming to generate images. And here we have an open source implementation, and this is a research paper published by NVIDIA in 2020. So let me actually see if I can find for you an image, and hopefully that gives you something that you can better understand the type of resolution we're able to deal with here. Hopefully that shows you a better example. Let's see what we can do. Open image, and right, so like I'll zoom in briefly here, but you can see right away that we're dealing with images that look and feel like the real deal. right? You cannot tell with your eye if this image is real. You cannot tell if this image is fake. So the only way today to tell if these images are fake is to use another artificial intelligence solution, whereby we're actually detecting for things like artifacts, etc. So Stylegan 2 today is one of my personal favorites for generating images. These images are of extremely high fidelity and extremely real, and so I encourage you to check that out. That will give you another glimpse of the tech. And let me just go back to my presentation so you can have a chance to further understand where we stand today. So, we've mentioned the 5 most popular generative models and the 5 most recent. One of my favorites is the Stylegan 2, released by NVIDIA. So where are we today? Today image generation is very, very possible. This technology is used by companies around the world. So I do want to emphasize that now is the time to generate something together. I have been in the AI space for some time, and I am more than happy to brainstorm with you to solve real problems, to figure out how this technology can be leveraged to create something that did not exist before. And I highly encourage you to schedule a call with me. And this call allows you to have a conversation with me one-on-one. And this call allows you to create something that is meaningful, something that is valuable. So let's backtrace and let's consider the benefits of artificial intelligence to generate images. So the benefits really is that now we have a system. We can now click a button. That's sort of the first benefit. We click a button, we're able to generate an image from nothing. This is called either unconditional or conditional image generation. Number 2, we're able to massively leverage AI technology to create value for the company. Usually that value translates to capital or revenue. So now the second benefit of using AI to generate images is we can increase revenue for the company. And the third major benefit of using generative models is that we can now actually crush our competition. So being ahead of our competition, being ahead of other companies who are not using this technology is one of the best ways that companies can get ahead. And if you're using this technology, that's amazing. That's a step in the right direction. If you're not using this technology, then I highly encourage you to think about what can you generate, what kind of image, what kind of use case, what kind of industry do you want to use it for? And if you're interested, I'm more than happy to actually have a conversation with you where we can talk more about this. So again, that call to action is you want to use image generation technology at your company, and the best way to do that is to schedule a discovery call with me where me and you can have a discussion on how you would go about it. And I highly encourage you to reach out. I highly encourage you to create a conversation, because I see generative models as one of the best ways that you can use AI technology today. They are the most promising, and yet the technology is readily available. Technology is available for those who want to use it. The real question is, what impact do you want to make? What kind of result are you looking for? And if you do have that vision in mind, if you do know what you want, if you do think image generation will help you, then I highly encourage you to reach out. And I remind everyone who is joining this live stream that this is a live stream whereby I aim to share insights. I aim to educate and inspire people, companies, and decision makers around the world to leverage AI technology to be innovative and to crush your competition. So if you're interested, feel free to subscribe. Hit the subscribe button. Be notified of upcoming live streams, and I am super excited to have you on this live stream, and I look forward to our next live stream where we aim to generate text using computer vision, natural language processing and deep learning technologies. Again, we're aiming to generate text using AI technologies. I think this is a very powerful use case that a lot of companies are now starting to explore. In the media space especially. And I am super thankful for your time. I am glad that you had a chance to check it out and learn more about how to generate images using computer vision and deep learning technologies. I look forward to seeing you next time.